In this clip, we'll focus on the use of the t-test to compare two different groups. And once again, we're faced with a really enormous data set, which again is rather intimidating. So I'm going to start off by just highlighting at least some of the top row. You can see this goes on and on and on, horizontally and vertically. Good grief. Okay. We'll give it a color just so that we can see it. And we can see that, again, as with a lot of these data sets, that the columns sort of run into one another. So sometimes it's good to separate them out. So what we're looking at here is a data file that's come from the National Health Service. It's looking at complaints received from different hospitals, trusts, etc. at different times. And looking at our first column, it looks as if it's the year 15, 16 and different quarters. So what on earth could you do with this data set? It's pretty numerical, so it's got a lot of scope for statistical tests in theory, but of course you could begin with descriptive statistics. You could calculate means, modes, medians, proportions, percentages, etc., if that's what you wanted to do. But the starting point is to really say, well, what sort of information can I get out of this? Well, given that we're comparing quarters, we can look at different time periods within 1 year. Given that we have different organisations, we can compare them. Right at the far right-hand side here, we have regions such as the north of England and the Midlands. We could compare them. Going back again, we've got, we may be interested, depending on what our focus of interest is, we might be interested in the complaints brought forward or the total of new complaints. We might be interested in the complaints pertaining to patients who are young or a bit older. We've got different age ranges here. So we've got various things that we could look at, and an awful lot of things like the status of the patient and the clinical area that they were undertaking treatment in, that perhaps we are not interested in. And so I'm thinking to myself, I think I know what I will do here. I will jolly well highlight quite a lot of these columns, which I don't think let's highlight them at the top, which I don't think I will need. Do that again. And highlight and hide. So just get them out of the way. Well, as I say, there are an awful lot of things one could do here, but I've decided that I'm going to compare two particular things for the purposes of demonstrating a t-test. So I've decided that I'm going to compare the total of new complaints, that's my column G here, and I'm going to compare those in two regions within the first quarter. And the two regions I'm going to pick are the north of England, and then going down a bit, the Midlands and east of England. So I'm interested in that column G that we saw just now, but I need to make a note of the rows that are relevant here. So it's row 2 to row 53 for the north of England, and then row 54 to row 91 for the Midlands. I'll need to remember that because I'm going to have to highlight the relevant parts of my column when I get to my t-test. So column G, if you remember, was the column I was interested in because that's the new complaints. So how do I go about undertaking this t-test? So just to remind you, first of all, that's the bit about hiding columns. And a little reminder about t-tests then. We need to go to our data tab in Excel, go to the data analysis region, and then select a t-test to sample, assuming equal variances. Now we could use the unequal variances as well, and in fact we'll try that afterwards. So first of all, then let's see how that works. So there's the data tab. click on it. Our data analysis section is over here on the right. Remember, we had to add that in specifically, and you might find that the version of Excel you have doesn't automatically come with that. So we click this, and hopefully it will open a little box here, a little dialog box, and asks us what we want. So let's have then t-test 2 sample assuming equal variances. If you remember, the t-test with pairs assumes that you've got the same individuals before and after something. So it could be the same patients before and after a drug treatment. It could be the same plant before and after putting it in the dark, or something or other like that. We haven't got that here. We've got completely different patients. So it's completely different samples. Okay. So now Excel wants to know what these 2 range of samples are. So this is where we have to remember our rows. So we're only interested in new complaints here, but we have to look at 2 different sets of rows because they conform to the 2 different regions. So if you remember, and I'm consulting my notes here, we want the north of England, which was row 2 to row 53. So I'm scrolling down here. I don't have to do too many, so scrolling will work here, but it's such a big data set that you wouldn't want to do too much of that. So that's that one. And then variable 2 carries on from that, from 54, there it is, down to 91. Where's 91? There. Okay. We'll hypothesize a null hypothesis that there's no difference between those 2 regions. There's no difference in the number of new complaints. Any difference is due to chance. We don't have, nothing that I highlighted had any labels in it, so I'm going to leave that blank. Alpha, the probability cutoff point, if you like, or confidence point that we're going to use is normally 0.95, and we'll keep it like that as well. And if you remember, what that means is that any probability smaller than 0.05 we can assume to be so small as to enable us to reject our null hypothesis, meaning that there is a significant difference. Whereas if the value of the probability is greater than 0.05, then we can assume, in fact, that there is no significant difference. In other words, we can accept our null hypothesis. Now, sometimes we can put the output range here on the same page, but there's so much data on this page that I think that would just cause messiness. So we'll have a new worksheet here. So click OK, and it takes us to a new page. And so we can see that it's calculated the means for the 2 regions, and it looks as if there was slightly more complaints in region 2, which was the Midlands. And what else has it got? What are we interested in? What we are interested in is the value of P. So we have a value of P equals, I can't make that big. If P equals 0.03 for a one-time test, that would be, and P is 0.07 for a two-tailed test. Now what this tells us actually is that if we assume that we're only interested in one end of the distribution, shall we say, then we can say that the probability is actually quite small, smaller than 0.05, and in fact we might consider then that there is a significant difference, that in fact there's a significantly higher level of complaints, new complaints in the Midlands than in the north of England. But that is a one-tailed test, and normally if you're sort of exploring, you would go to the two-tailed tests. Certainly it is not at the level of P is not so very small as to make us really keen to point this out. It's not that different really. And just out of interest then, if I go back to my data, let's see how that would work if we actually did the test with assuming unequal variances. And this is what you should do in theory if you don't really know what those variances are. So once again, we go through the same sequence of highlighting, making sure we have the right column, complaint new, starting for the north of England 2 to 53. And there it is there. And then variable 2 just follows on from that. 54 down to 91. They're not necessarily the same number in each group, you notice. That's okay. Again, we assume no differences on null hypothesis, and we'll click OK. It's opened another sheet now to do this. And if we have a little look at our p-values now, then you'll notice that they've gone up. In other words, it is harder to find statistically significant differences where you assume unequal variances. This is almost as if we're biasing it to make it harder to find that difference. And that's a fair thing to do, because it could be that if the original parameters of these populations were very different, they weren't from rather similar distributions, then maybe it's not fair to compare them in typical statistical tests. However, in theory, the one-test test is still slightly significant, although 0.047 is really very close to 0.05. So this is, it's on the borders really. And certainly if you were, I don't know, the director of a health board, you'd notice perhaps that there's definitely more new complaints in the Midlands than in the north of England, but you might be a bit wary of shouting about it too much, perhaps. So that was our data again. Just remind you of the main test, and we'll stop there at our t-test.